Good evening, and welcome to Argonne's National Laboratories Virtual Out Loud. I'm Robin Grange, Head of State, Local, and Regional Public Affairs and Outreach, and I'm pleased so many of you have joined us for this forum. Let me begin by just sharing a few housekeeping remarks to help you get the most out of tonight's event. Your video and audio were automatically turned off when you joined this event. Automated closed captioning is available during our session. If you would like to use this feature, at the bottom of your screen, click on the live transcript and choose one of the two viewing options. If you have any questions related to the technology of this meeting, for example, if you can't hear or see the presentation, click the Q&A icon on the bottom of your screen. Send us a message explaining the issue you're facing, and our AV team will respond and help you troubleshoot. Please note that today's session is being recorded, and we will make it available for viewing post-event. By participating in today's session, you consent to being recorded. Now, it's my pleasure to introduce Suresh Suresh, I'm destroying your name, Sunderrajan, our Associate Laboratory Director for Advanced Energy Technologies. Suresh leads an organization of scientists, engineers, and analysts working to enable a sustainable, secure, equitable, and prosperous energy future by solving today's most pressing energy, transportation, materials, and manufacturing challenges. The Advanced Energy Technologies team addresses these challenges using the laboratory's world-class scientific and engineering expertise and facilities, and by collaborating with internal and external partners on cutting-edge research, development, demonstration, and deployment of clean energy technologies. Some of that very work we're going to be highlighting tonight. Suresh, forgive me for destroying your beautiful name, and thank you for being with us this evening. The floor is yours.
Thank you so much, Robin. Good evening, and welcome everyone to our Out Loud lecture. I'm Suresh Sunderrajan, as Robin mentioned, and I have the distinct privilege to serve as the Associate Laboratory Director of Argonne's Advanced Energy Technologies Directorate. Now, over 50 years ago, air pollution, gas-guzzling cars, and chemical waste disposal in waterways were not regulated as they are today. These were commonly accepted as signs of technological progress and of a thriving economy. Most Americans remain largely oblivious to the environmental concerns and how a polluted environment threatens human health. Senator Gaylord Nelson, then the junior senator from Wisconsin, had long been concerned about the deteriorating environment in the United States. In January 1969, he and many others witnessed the ravages of a massive oil spill in Santa Barbara, California. Inspired by the student anti-war movement at that time, Senator Nelson wanted to infuse the energy of the student anti-war protests with an emerging public consciousness about air and water pollution. Senator Nelson announced the idea for a teach-in on college campuses and chose April 22nd, a weekday falling between spring break and the final exams, in order to maximize student participation. So on April 22nd, 1970, we had our first Earth Day. What began as a student movement is now a global day of action to call attention to the need of being good stewards of our planet. Today, the clarion call is to address climate change, to understand better the causes, mitigate the negative impacts, and adapt to its effects. Argonne's talented scientists and engineers are advancing science and developing technologies to address climate change impacts and to support the nation's pollution reduction and decarbonization goals. Before we begin our discussion, we have a brief video on how Argonne is leading the way to decarbonize our country and our world.
The problem is climate change.
There's simply too much carbon dioxide in the atmosphere.
It's getting worse.
We can see it in these, once in a lifetime weather events that are now happening with with more and more frequency. No one knows what will happen if we don't do anything about it, but I don't think any of us really want to find out.
So my name is Nicolas Stoff, and I work at the Argonne National Laboratory, where I'm the manager of the Nuclear Applications and Economics Group. The challenge in meeting the decarbonization goal is that we don't have much time. So the current nuclear reactors that have been deployed very successfully were meant to generate electricity for full cities. Those are extremely complex to build and expensive. The industry is moving toward smaller reactors so that they can be built at lower risk and smaller footprint so that they can serve different markets, different regions.
My name is Karen Mulford. I'm a chemist at Argonne National Laboratory. My group is part of a team to understand the fundamental science behind direct air capture of carbon dioxide. To decarbonize, we need to take existing carbon dioxide out of the atmosphere. And capturing it directly from air doesn't require any kind of extra energy input from concentration. If we can design the ideal molecules and materials to do this, we'll just pull the carbon dioxide out of the air, that, the excess that doesn't need to be there.
My name is George Crabtree. I'm director of the Joint Center for Energy Storage Research, which we pronounce JCESR, at Argonne National Laboratory. One area that's very hard to decarbonize is heavy industry. And that's because heavy industry requires a lot of high temperature heat. It's relied on fossil fuels. If you say we can't have the carbon emissions from fossil fuel combustion, what's the alternative? Well, actually there are alternatives. One is very clever, I would call it next generation, electrochemistry. So instead of using what's called thermochemistry, so you get all the heat from burning fossil fuels, and that drives chemical reactions. Turns out you can do that with electrochemistry. You provide an electrocatalyst that you have to discover. You can get the same outcome, the same chemical reactions can be driven by voltages and electric fields at ambient temperature, and you don't need the fossil heat.
It's not just enough to capture the carbon dioxide. Ideally, we would turn it into another carbon-based fuel that we could use in a typical combustion engine, and this would be sort of part of the circular economy. Turn it into polymers, plastics, sort of value-added products. That's a pretty important part of the decarbonization effort as well.
So the lab is unique because when it was founded 75 years ago, it had a mission to develop the US nuclear industry. And since then, we have been working in the development of advanced nuclear reactors, and really is leading in this area.
Our team has experts ranging from molecular design to X-ray spectroscopy to ultra-fast optical spectroscopy to computational chemistry. Our group routinely uses the advanced photon source to do a variety of X-ray experiments that will help us understand what our molecules and materials look like and how they behave under real-world conditions.
And Argonne is fortunate that we're having Aurora installed that will bring Argonne back into the top 10 fastest computers in the world.
I think bringing together many different areas of expertise to have a very holistic perspective. So the impact of this work, I think, is hard to underestimate, right? We hope the impact of our work in this field is to understand the fundamental science so that it will advance the next generation of a technology to do this on a national and global scale.
You may say that climate change is one of the signature challenges of this century. We have to make sure that we have processes and technologies that don't emit carbon. It's a challenge that, looking back, we'll say, I'm so glad we did that. It's saved us so much risk, so much cost, so much imposition, so many lives, and just so much inconvenience.
I'm sorry about the couple of glitches, but I hope you enjoyed the video. And I hope you saw that, Argonne has a broad and deep portfolio of high impact research and development programs focused on decarbonizing the entire economy. Our world-class community of talent is taking a whole of lab approach to address this grand challenge. I hope you also take away from the presentations this evening that our advocacy of clean and renewable energy is consistent with the lab's commitment to employing sustainable practices, to advancing and clean energy and renewable energy research and development, and in being a responsible member of our global community. To discuss these today, we're joined by our sustainability program leader and two of our talented scientists. Together, their work promotes comprehensive sustainability practices and advances decarbonization science that protects our planet. First, we'll hear from Catherine Hurley, Strategic Planning and Sustainability Program Manager in our Infrastructure Services Division. She provides strategic direction and management for Argonne's Site Sustainability Program. Catherine will be followed by Bryan Nystrom. Bryan is a senior software engineer in the Energy Systems Division. His research is focused on improving the interoperability and charging capability of electric vehicle charging stations, making power more available and reliable to meet the increasing demand for electric vehicle infrastructure. Our final presenter is Yuki Hamada, biophysical remote sensing scientist in Argonne's Environmental Sciences Division. Her research is focused on developing an artificial intelligence platform to monitor bird activities around large-scale solar energy facilities to examine the potential impact on bird populations. They will tell us about their work, and then we'll take some time to have a conversation. As you're listening to our presentations, if you have a question, please click on the Q&A icon on your screen and type in your question. We will try to address as many of these questions as time allows during the Q&A portion of the program. At this time, I'd like to turn it over to Catherine. Catherine, please take it away.
Thank you, Suresh, for the introduction, and good evening, everyone. So glad to be here. Next slide. So at Argonne, we are passionately committed to a sustainable world, and sustainability meaning that we meet the needs of our current generation without compromising the ability of future generations to meet their needs. And eliminating carbon emissions is the most pressing sustainability challenge we face. And as you just heard in that wonderful video, our changing climate is threatening everything we care about, and it will continue unless we take action. And we don't have a lot of time. Argonne is uniting our science and technology with campus operations to decarbonize the laboratory and to help the nation and the world meet this challenge of the century. Tonight, I'm pleased to talk about Argonne's campus sustainability program and our plans to achieve net zero emissions at the laboratory. I'll also point out a few research collaborations that will be further highlighted by my colleagues later in the presentation. On the next slide, you'll see that at Argonne, we take action to address sustainability and environmental issues on our campus through a three-pillar collaboration. Environmental protection ensures Argonne activities are conducted in an environmentally safe and sound manner in accordance with existing Department of Energy requirements and Argonne permits. Site Sustainability Program focuses on the proactive implementing of practices that conserve energy and water, divert waste, reduce fuel consumption, and reduce pollution. And our Natural Resources Program manages our 3-square-mile campus that contains woodland, grassland, and wetlands to improve quality, reduce invasive species, and protect threatened and endangered species. Tonight, I'll focus on the efforts and impact of the Site Sustainability Program and also show how we all collaborate at Argonne to care for the environment. In the next slide, you can see our visualization of the strategic plan for Argonne's Sustainability Program. We begin with 4 key strategies that are in the blue circle. Our program is anchored on the need to meet Department of Energy goals, which now include serving as a model for the nation to achieve a net zero carbon emissions by 2050. We also seek to optimize and upgrade our infrastructure through facility and utility upgrade projects. We engage the laboratory community so all members of Argonne can help us achieve sustainability goals. And finally, we work to institutionalize sustainability or make it a common practice. These strategies are then implemented through a focus on 4 disciplines or technical areas. Smart Labs seeks to optimize laboratory buildings for safe, efficient, and sustainable operations. Clean Energy discipline seeks to install on-site as well as purchase off-site clean and renewable energy. We have several on-site solar energy systems at the laboratory right now. And later tonight, you'll hear from Yuki, who will talk about how our solar systems on our campus were used in her important research. Under our mobility discipline, We address travel to and around the laboratory with greener transportation options. And finally, resource conservation seeks to reduce our material use and improve waste diversion and recycling. Our whole strategic plan is centered around good planning, effective communications, and resilience. Now, we annually develop specific projects and deliverables that align to this strategy, and I can tell you we are achieving very strong results. I'll now highlight a few of these areas in more detail. On the next slide, we talk about our Smart Labs program, which we created to take a holistic approach to improving performance of our buildings. Now, this is especially important because at Argonne, our laboratory buildings, which is typical, use 3 to 4 times more energy than a regular office building. We implement a comprehensive process that seeks to deliver safe, efficient, and sustainable laboratories. The process that we take is shown on the right. We start with the goals and then complete a thorough assessment of the building performance. We identify renovations and equipment modifications that can improve the performance of the building. And then we also establish a performance plan to ensure that the building systems can maintain their efficiency over time. Currently, we are actively implementing our Smart Labs program at 12 buildings across Argonne's campus. Since we started this program 5 years ago, we have already identified $1 million in energy and water savings and have completed 5 projects. Argonne's Smart Labs efforts were recognized by the Department of Energy's Better Buildings program with their annual award in 2019. On the next slide, we talk about mobility. We have a robust network of electric vehicle charging stations installed on site. They are used by our fleet vehicles, by our researchers, and our employees to reduce carbon emissions from vehicle travel. Today, we have 36 level 2 charging stations across our 3 square mile campus. Employees can participate by paying a use fee that covers the cost of electricity and equipment. We have 110 employees currently participating in the program, and it's growing every day. Our electric vehicle charging program is part of a collaboration with Argonne's Center for Transportation Research. Early electric vehicle charging stations were installed by our researchers. Employees were then allowed access for vehicle charging, and researchers were able to collect important data from the equipment. That program started with just a few participants, and now, as I said, have grown to over 110. This partnership continues today. Employees will be testing a new technology that center researchers are working on to enable the first generation electric vehicle charging stations to become smarter. My colleague Bryan Nystrom will talk about these research efforts in greater detail during his presentation. On the next slide, we talk about our lab-wide recycling project, which is a great example of collaboration under the resource conservation discipline. This project provided a focused effort to recycle and properly dispose of material that was taking up spaces in active work areas, kind of like spring cleaning. And similar to a community recycling drop-off event, the program was open to the whole lab community. And we actually had it occur over a full week in July. Now at Argonne, to ensure safe practices and that we complied with our own policies for paperwork and reporting, our internal moving group picked up materials from the customers rather than having all the customers have to bring their stuff to one designated spot. It was great customer service. In 1 week, we collected material from 35 different buildings around the campus, which included 30 metric tons of electronics recycling, 36 metric tons of scrap metal, and 24 metric tons of solid waste. Just to give you a size of the scale of this effort, this is the amount of material Argonne would normally collect in 1 year, and we did it safely in just 1 week. This project was a successful collaboration across the lab between all the different operations organizations and our researchers, and it did also receive an award from the Department of Energy Sustainability Performance Division and the United States Environmental Protection Agency. Now on the next slide, we look forward. Our sustainability programs all have one common goal: to reduce carbon emissions. We have been investing in sustainability for over a decade, and through our strategic investments, we've reduced our carbon emissions by 40% below a 2008 baseline. Now, over the last year, the White House and Department of Energy have set the goal to reduce carbon emissions all the way to zero by 2050. To support these goals at Argonne, we've developed a strategic plan to reach the net zero carbon emissions. To develop this plan, we built a computer model, or what we call the digital twin, of our facilities and our infrastructure. The digital twin allows us to simulate the impact of different strategic decisions so we can maximize our investments to reduce our carbon footprint. Using the digital twin, we are focused on two key strategies shown on the slide: reducing our energy consumption and decarbonizing the energy we do use. The simulation on the right represents our digital twin. You can see in most cases those bars decreasing as we implement the plan over time. We are also fortunate to have two large research facilities coming online. However, they will be energy intensive. So this is reflected with the increases in carbon emissions as represented in the digital twin. So that's why you see a few of those bars spike up when other ones are going down. As part of our strategic plan, we will capture the heat from those facilities through recovery technologies for reuse at the lab, effectively offsetting a large portion of the energy use. A foundational component of our strategy is having our electricity grid become greener and have less emissions as part of our electricity over time. But even if the electricity grid is slower to become green, we can still make major impacts by adjusting our decisions and investments at the laboratory. Based on our analysis, to get to net zero emissions by 2050, we need to significantly accelerate the key strategies that we know work today and prepare for the emerging technologies that will be commercialized in the next several decades. So looking at the next slide, the next steps for our sustainability program is to finalize and begin implementing our carbon emissions reduction strategy. This work is simultaneously a sprint to get started, but a marathon in duration. First, we're increasing laboratory education outreach to engage the whole laboratory community in these efforts. We have rolled out a lab-wide outreach series called Let's Talk Decarb and are sharing the message about our challenges and our solutions with all employees. We are also developing new collaborations across the campus. We're building upon our existing robust sustainability program and engaging new stakeholders, including scientific subject matter experts and partners. We've also formed new cross-disciplinary working groups to refine our net zero carbon emission strategy. And finally, we're developing our roadmap to action based on our refined strategy. This will ensure that we are investing today in the right strategies to achieve our long-term goal. We will continue to use our digital twin and other tools to establish our investment strategy and track progress. And we will incorporate new ideas identified during these new collaborations and working groups coming from the researchers in campus planning. So the next slide, I thank you for the opportunity to share our efforts to advance and practice sustainability at Argonne. For more information, you can visit our website at the link shown here. And next, I'd like to introduce Bryan Nystrom, Senior Software Engineer from Energy Systems Division, who will be our next speaker and is one of our key collaborators on the Employee Electric Vehicle Charging Program. To you, Bryan.
Bryan, you're still muted. Not yet. Try again.
Hello?
There you go. Thank you.
Does it work now?
Very good.
All right, I'm sorry. I'll start. All right. Well, first, thank you, Catherine, and thank you all for joining us tonight. Sorry about that. My name is Bryan Nystrom, and I'm a senior software engineer working in the Energy Systems Division at Argonne. Specifically, I work in a group that's focusing on smart grid and electric vehicle charging infrastructures. Before we go to my first slide, I'd like to give you my definition of smart energy. So my definition of smart energy is that through the use of digital communications, the monitoring, measuring, and controlling of all aspects of energy producers and consumers, it's the ability to make smart decisions about how we use our energy. So with that, we'll go on to the first slide. So Argonne National Laboratories recently celebrated 75 years of operation. That's a long time to be around, and we've seen many changes and advancements in both energy and transportation technology. Back in the 70s, as Suresh had alluded to earlier, gas was all the thing. And actually on our campus, we actually had a full working gas station for the employees, for the benefit of the employees. During the day, you could go get gas in your car, fill up your tires, even drop your car off to get the oil changed while you continued to work. Well, as time progressed, of course, the surrounding suburbs grew up, and now you can't drive more than a couple blocks without hitting a gas station on your way into and out of work. So the old gas station on the facility was shut down and sat idle for several years. About 5 years ago, the division that I worked in decided to repurpose the old gas station and the site that it sat on. On the left, you see a picture of the old gas station, and on the right is the new smart energy plaza that we've turned it into. It's a research facility for us and also a place for employees to go and charge their electric vehicles. Moving on to the next slide. What you're seeing here is a screenshot of one of our live site visualization tools. If you would like to, there's the URL at the bottom, iot.ioc.ano.gov. This is always up and available for the public. That is the site of the old gas station, the Smart Energy Plaza, and we monitor all aspects of energy going into and out of our research laboratory there. You can also see anytime a car is charging, we have 12 level 2 charging spots there for employees to charge at. There are 2 DC fast chargers and 2 extreme fast chargers. Now, these extreme fast chargers aren't shown on this visualization quite yet. They were just recently installed during the pandemic period here over the last year, and we haven't had a chance to upgrade this grid yet. But also on the picture, you'll see we have 2 solar canopies above our level 2 charging stations. They're capable of 80 kilowatts of peak energy power, and we also have a 1 megawatt battery storage system, also not shown on this system. And going to the next slide. All right, so one of the challenges that we have is speedy charging is what I'll call it. Currently today, there are what I would consider 4 different levels of charging. And what we're going to talk about here is the electric vehicle supply equipment, EVSEs. They're otherwise commonly known as the car chargers or electric chargers, or sometimes called charge points. Starting at the bottom, you have level 1 and level 2 chargers. I'm only showing a level 2 charger there. Those are AC chargers. They would be something that you would possibly have at home to charge your car or at various places. They're excellent for charging your car at a place where you plan to have your car sitting idle for several hours at a time, because those chargers generally take a longer amount of time to charge. And if the car's just sitting there, why not let them slowly charge? Next in the list are DC fast chargers. They, of course, as the name has, they use DC charging power. This 50 kilowatt one, as you can see, this 50 kilowatt DC fast charger can charge in 2 hours what it would take a level 2 charger about 8 hours to do. So you can see where there's going to be more and more demand for getting fast charges using things like that. And at the far extreme, or what's the leading technology right now, is called extreme fast chargers. Extreme fast chargers are even faster than DC fast chargers. The problem with DC fast chargers and extreme fast chargers, they're not something that you could afford to or want to have installed at home. They're more likely to be at charging plazas similar to our Smart Energy Plaza, or when you're going on long vacations or trips where you don't have a return path home and want to get a quick charge really fast. So what's wrong with doing a quick charge? Well, a quick charge puts quite a strain on the grid, the smart grid system that we're pulling power from. If we advance my slide one more here, what I have a picture of is what's commonly known as a peaker plant. So what happens when systems like DC fast chargers and extreme fast chargers start putting a spike, want to get a spike of energy from the current grid? The current grid, in order to keep up with that demand, will then call on older carbon emitting power plants, coal emitting power plants, such as the one shown here, to pick up the peak load that it can't supply. That's why these are commonly known as peaker plants. Of course, we want to avoid having those be employed, because they do pollute the air, and that's something we're trying to avoid. So how do we address this? Moving on to my next slide. Here is the picture of our extreme fast charging station that we just had installed. In the picture there, of course, is our beautiful Porsche Taycan. It's one of the few cars available currently today that can take advantage of an extreme fast charge. But of course, as you know, as time goes on, more and more of those types of cars will become available. In the background, that square container, shipping container looking box back there, that is our battery energy storage system. It is a 1 megawatt battery storage system. To give you some perspective on that, if that battery alone has enough power in it to charge 7 Tesla electric vehicles without ever pulling any power off the grid. So it stores quite a bit of energy on its own. So how do we utilize that? Well, when a car such as the Porsche or a Tesla pulls up to an extreme fast charger or DC fast charger, and it starts to look like it's about ready to put a lot of strain on the normal grid, what we will do is at that point, we will kick in the battery energy and start utilizing the battery energy along with our grid energy. In that case, the grid will never see that spike of energy. And in that case, the possibility of them employing a peaker plant is less and less likely. So those are the types of things that we research and help put out into the general public. So in the future, there's less likely chance of us calling on non-clean energy for use with electric vehicles. So going on to the next slide, I'd like to just show a few more of the ways that we are helping advance the adoption of electric vehicles and clean energy. The top device you see there is our smart charge adapter. It's a little device that you can get that will plug in between what I would call a not smart electric vehicle charger, one that doesn't provide very much information back to the user, and the electric vehicle. What it adds is a wireless digital communication back to a smart application where you can monitor all of the aspects of power and energy going to your car, also let you delay and start charging during non-peak hours, which helps with the reduction in the amount of energy that would be used. The device below is our spec module. The spec module is a device that's currently deployed in a lot of DC fast chargers that are already out on the market. A DC fast charger manufacturer can put one of these spec modules in their DC fast charger, and it allows for the DC fast charger to have digital communication back with any number of different types of cars that can take advantage of DC fast charging. And last but not least is our EV REST application that's currently in development. This helps places such as Argonne distribute this application to users of our electrical charging system, let them make reservations, and when a user pulls up and wants to make a charge, they can let us know how long the car can sit there. They can come up and say, oh, I plan to let my car sit here for 2 hours, but I only need 30 miles of charge on my car. And then we can make smart decisions on the best way to charge that car so that when the employee returns back to pick up their car, they have the exact amount of energy that they needed to make it home or to their next stop. So I know you might have plenty of questions about some of this stuff, and feel free to put those in the Q&A section. But at this time, I'd like to go ahead and turn it over to Yuki Hamada, who is from our Environmental Science Division. Yuki, take it away.
Thank you, Bryan. That was a very fascinating technology. Thank you for sharing. And thank you all for joining us today. I wanted to start my presentation with a big shout out for my colleague, Adam Zimansky. He is the technical lead for our project developing bird monitoring software, so solar energy facilities using machine learning. You may wonder why we are interested in monitoring bird at the solar farms. And I'm going to describe for the next few slides why we are doing this project, working on this project. So the solar power is one of the fastest growing clean energy in the United States. This year alone, solar is expected to create nearly half of the new electricity generation capacity in the country. But the more solar farms, meaning the more land will be covered by solar panels. So the question is, what does that mean to our environment? So the next slide shows the bird flying over the solar panels. So about 10 years ago, people started noticing the bird may be colliding with the solar panels, creating fatality. So the estimated incidence that the bird collision at the solar farm is very limited compared to other causes of bird fatality. But we don't know the full extent of the issue because there is not enough data to study, and then the bird collision data are very difficult to collect. So the Argonne and the US Department of Energy Solar Energy Technology Office recognize the need for automated method to collect the data on bird interactions with solar energy infrastructure. In March 2020, the Argonne started developing the bird monitoring technology. So the next slide shows some of the graphics that related to our technology development. The choice of our methods was a combination of computer vision, machine learning, and edge computing. Computer vision is how computer sees object in target and the patterns in the image. Machine learning is a part of AI that focusing on training the computer to learn about the targets, just like us human beings learning about those things. Edge computing, meaning the processing data on the device, and only essential information will be sent back to users or server. The first thing we did for this project was collecting the training data. In our project context, training data meaning the data set that describes how birds would look like in the video and how they move when they engage the certain activities. So those data did not exist when we started this project. So we partner with solar farms, bird experts, and Argonne's sustainability program to start collecting the video near solar panels. So far, we have collected over 10,000 hours of data and video, and we have been labeling the birds and their activities manually to create the training data. Using the data set, we train the model to develop the bird monitoring software. The model is still in development, but our current preliminary model detects the birds at 97% accuracy and classify bird activities between 76 and 96% accuracy. Once our technology development completes, the bird monitoring at the solar farm will look like this. When bird flying near the solar panel, the model automatically detects the bird and start tracking the movement of the bird, just like as we see in a green box and a line in the slide. The model will classify the bird activities into several categories: collide with panel, fly over above at sky, and fly through between panels, or perch on the panel, and land on the ground near panels, or combination of those. The small animation in the slide shows an example of the combination of fly through, the bird flying through, and fly over above the panel. All of these steps will be done in the camera, and the result will be sent to the solar facility personnel. So we started this project prompted by the bird collision with solar panels. But Argonne is going beyond the studying the negative impact of solar. As you now know, that we designed our system to recognize a variety of bird activities, not just collisions, so that we can study and discover the potential benefit of solar energy development on birds. For example, shadow from the panel may create a cool place for birds to rest during the hot summer. The plants or vegetation on the ground could provide food sources. And solar farm itself may be a safe place for the bird to nest because perimeter fencing keeps predators out. So solar power is growing faster, more, and changing our landscape. The technology we are developing will help sustainable growth of solar power. Would it be nice that we can power our home with clean electricity and we can still enjoy the nature around us? By the end of 2023, our bird monitoring system will be ready for a large-scale field trial at the solar facilities across the country. Thank you for your attention, and I will turn it back to Suresh.
Thank you, Yuki, Bryan, and Catherine for your presentations. I think the research you're doing is fascinating, and truly I can see the connections of how you're accelerating the science that will, significantly reduce harmful carbon emissions and protect the planet. We'll move now to the Q&A portion of the program. I want to encourage the audience to put any questions that you have in the Q&A chat. I will use this opportunity to send my first question to Catherine. Catherine, this is a question from the audience. Can you talk a little bit about the recycling efforts going on at the lab? Where are the recycled items going for processing, and what forms do the processing take?
Yeah, great. Thanks, Suresh, and thanks for the question. So we do have lots of different recycling programs at Argonne. The most basic type of recycling that people might think of is similar to your household recycling. We actually have a contract with Republic, which is a municipal solid waste company that both picks up garbage as well as picks up recycling. In that case, Republic takes the recycling to a separation facility. And I actually toured one not that long ago, and they use optical sensors and lots of interesting huge machines to separate all the items. So even though we have commingled recycling where paper and plastic and aluminum all goes in one big bin, they actually separate it at the facilities. And then the centralized facility then has contracts with different companies that take these big baled, almost like they're cubes of aluminum or of paper or of different kinds of plastics. But at Argonne, because we're also more than just a small city, we're almost like a large industry. We do have special waste streams like scrap metal, which actually go to companies that then melt the metal down and turn it into other products. So we have a wide variety of programs that take other items besides things you can put into your municipal recycling. And we have competitive contracts and make sure that all of the paperwork is good and that the products are actually going to turn into products that are helpful and reduce our use of natural resource and raw materials.
Thank you, Catherine. Great answer. My next question is actually directed at Bryan. Bryan, this is a popular question. At least a couple of folks have asked about the possible negative effects of super fast charging on battery life. Could you talk a little bit about that?
Sure. The group that I work in doesn't directly look at those things, but we do have groups at Argonne that are specifically looking at battery technology and things like that. But you're correct. DC fast charging or fast charging of any battery in a vehicle currently is, if you're familiar with fast charging your phone, the more you fast charge your phone, the more it's going to degrade the battery. Over time, fast charging is not a good thing. If I were to own an electric vehicle, I wouldn't do 100% of my charging on a DC fast charger. Charging at a slower rate, it's a slower ramp up rate, and letting it take longer to charge is less detrimental to the battery. It has to do less conditioning and stuff like that. So we do look at those things, and yeah, DC fast charging is not necessarily at the moment with current battery technology, it can degrade it as you mentioned. So.
Thank you, Bryan. Yuki, this question is coming to you. Is there some differentiation on how different species of birds react to renewables, specifically solar, presumably? The person posing the question is specifically thinking about piping plovers in Chicago and bald eagles.
Yeah, that's a very good question. And our technology is currently we started with bird and non-bird distinction to just have the first step. But definitely that is the most frequently asked question, that the understanding of differentiating different type of birds or species so that we can study and understand if there any difference in the different bird respond to those energy infrastructure differently. And that is a good question. And we hope that our model or system will gather the data to start answering those questions.
Thank you, Yuki. So important. The data is key. Very much appreciate that. Catherine, coming back to you, the sustainability program that you described for the laboratory is quite comprehensive. You talked some about next steps as well. Could you share one or two specifics about the next steps that are being planned for implementation at the laboratory?
Yeah, thanks, Suresh. So as I mentioned, we annually go through a process of identifying specific projects to implement. And right now we have around 4 really high impact projects to help reduce our carbon footprint that are on the docket. One of them is a retrofit of 3 different laboratory buildings that have end of life ventilation and heating systems and have lots of continuous airflow for safe operations of the laboratory. So we've put together a proposed plan to retrofit those 3 facilities. It'll reduce the carbon emissions of those buildings by 40 to 60% by replacing all of that equipment, upgrading the controls, and ensuring that we're getting the safe, effective amount of ventilation, but not over-ventilating spaces that isn't actually giving you any value. So we have put together a proposal for that and are actively working with the laboratory leadership and with the Department of Energy to see how we can fund that project. The other key thing we are doing is updating our design standards. So even small renovations or other improvements at the laboratory that we're doing because they're already planned and funded, that we're incorporating to the greatest extent possible sustainability approaches that look forward to how we need to be reducing carbon in the long term, so we can make better use of every investment dollar we have today, even if it's not specifically being done because we're trying to reduce emissions. We can get some emissions for free at the same time. So yeah, those are 2 great examples.
Fantastic. Thank you, Catherine. Bryan, another one for you. As EVs are becoming more available, power generating plants and the ability for the transmission network to supply the load is certainly a question. It seems that the rollout of EVs is quite dependent on the availability of shall I say, better transmission and distribution. Do you have some thoughts on the plans to upgrade power systems to new requirements?
I think it's an ever-changing landscape on both the grid side and the EV market. On the EV side, like I mentioned earlier, it's kind of a race between the EVSE manufacturers, those that are putting out the EV chargers, and the EV cars themselves to see who can come up with the fastest system, because that's kind of what consumers want. But on the grid side, like we said, it wasn't initially set up for loads such as we see. So we're hoping the adoption of, alternate, like battery storage systems and stuff in the near future helps alleviate some of that stuff. Down the road, I'm not sure. I mean, that's more up to the electric utilities and stuff like that on how they're going to adopt to more pick up that stuff. We don't have, we help guide them, but I don't know that we have that much say in what they do in the future. But I certainly agree that the back end infrastructure needs to keep up or change in some way. And nuclear power plants and other clean energy systems coming online certainly helps in that effect. So,
thank you, Bryan. Yuki, a follow-up for you. What is the most surprising thing you've learned about birds' interaction with solar panels?
The most surprising thing is how diverse the interaction is. As you probably noticed in my talk, we only selected the 6 activity types of the bird. But because we did not have the data, the continuously recorded the bird activity data until our project, So, but once we go to the video, many activities do not really fit into any of those categories. So we can discover that is how diverse the movements are. And also another important things we recognized was that we categorize the activities, but what does that mean for ecology or bird population? For example, perching on the panel, what does that mean for bird population or their survival and reproduction? So in order to understand the benefits of the solar or clean energy development for the wildlife, meaning it's important to translate the data we are collecting into the knowledge so that we can really understand and quantify the benefit. So that's something we were fascinated to learn through our own project.
Fantastic, Yuki. Thank you. There's several more questions coming in from the audience. We've clearly got an engaged audience. So let me do another round if that's okay. Catherine, this one perhaps to you. Do lab sustainability projects provide a test market on campus for, the question specifically talks about innovative battery technology, but I think that could be extended to other research areas as well that are being researched as part of Argonne's larger mission.
Yeah, great question. So I think actually, as I maybe alluded to, this partnership we had between the Site Sustainability Program and Energy Systems Research that Bryan's group and your organization, Suresh, have been involved in has been a really neat evolving partnership where the researchers need users, right? They need vehicles to plug in and they need people to use the equipment. So we have been having this longstanding relationship, whereas the new technologies and external partners are interested in bringing things to Argonne, Argonne can say, yes, we are, a test bed and demonstrating these and are able to actually connect them to this group of 110 employees that are participating, which have a really big diversity of types of vehicles and charging habits. And so that's been one of the really exciting parts of our program. And then I think Yuki, as she was looking at this idea of creating the machine learning work, it said, hey, we have this solar PV photovoltaic system on campus. Can we use that rather than having to travel somewhere far away to find some other solar array we could have access to? So sometimes we have the site sustainability infrastructure first, and researchers can see it and say, I have an idea for researching there. And sometimes the researchers say, we'd like to do a test or a demonstration for a project. Can we plug it into real users and real applications? And so it's a really great two-way street that we're actively working on and are always looking for the next ideas that we're going to be implementing together.
Thank you, Catherine. Bryan, one more for you. It is an interesting question. Is it wise for thousands of places to have battery storage of charge rather than to have a fewer centrally owned and managed set of locations, owned and managed by a power company? Is the distributed, highly distributed model better than a centrally managed model?
I think probably my answer to that is it's probably a combination of the two. I don't advocate having, even though they're not all that large, but having large batteries sit on sites, every site that's going to have a DC fast charger in order to pick up and take over the load. The other problem that we have, though, is convincing utilities to adopt the use of battery storage. In some cases, it just seems like they're not interested, or it isn't in their best interest to maintain and operate those things. So some combination of non-centralized or localized and centralized battery systems throughout the thing is probably going to be in the future the best thing that we can have, unless we can find an alternative way of doing it other than battery storage and stuff like that. But like I said, it's a matter of convincing also the utilities that it's in their best interest to do that. So.
Thank you, Bryan. Yuki, one more for you. Will the bird solar farm studies that you're working on be able to determine any impacts on migrating birds that use magnetic fields to migrate?
Wow, that's a good question. I have to think about that. But I think that the migratory birds is a very, people are concerned about how they would be affected by those large man-made features on the landscape, especially that those structures did not exist before, and how they respond to that. And sometimes some people think that the glare or reflection of the panel may look like a large water surface, like a lake or pond, or sometimes those polarized light make because of that, if the bird may disorient, and may lead to some unexpected outcomes. So, but we again, this our project is really the start to collecting the data for the various questions that the audience asks. So many questions that I see the chat and the Q&A, and those are really the questions we wanted to keep notes to see how we could improve the data collection to answer these questions. And we are very excited that I really appreciate the audience's question today, that it kind of inspired me to kind of advance our research and science.
No, excellent, Yuki. Thank you. Bryan, I'm going to ask you one more question, and then I'm going to ask a question of the panel as a whole, if that's okay. And that might be our last question given time. But Bryan, this question is to you, and I'm actually going to I'm going to take a couple of them and kind of ask the questions together. Questions around kind of the future of EV charging. Is it wireless charging? Is it interchangeable batteries? Where you just drive in and you just flip the battery and you drive away with something that is fully charged. Any thoughts on where the technology is going?
If I could answer that, I probably would quit Argonne and retire a millionaire. I think we have seen in the industry come and go, different places trying to adopt both of those things. We have actually a few years ago installed some wireless charging spots at Argonne itself. That seemed to kind of not work out as well as what we thought it was. There was a lot more challenges in that than what we foresaw. But I could definitely see in the future, though. I'm excited about some of these things where they're thinking of putting a wireless charging spot under every parking spot that you could possibly pull into, and which would eliminate this whole people not being able to get to charging stations when they need to because other internal combustion cars are sitting there or something like that. The replaceable, quickly swap out a battery is also an interesting idea. But the challenge with that particular one, in some cases, is the fact that one battery shape and size doesn't fit all vehicles out there. Every different vehicle out there has got a different size of their battery and position where it's at on their vehicle and stuff like that. It would take a lot of future planning with a lot more standards in place in order for a good swappable battery system to come in place. But places like Tesla, I know they have tried that out. And I think that's still available, where you can actually on your trip pull into some place and they'll pull the battery out and put another one in for you. But very interesting ideas, but I think that those are very much future thinking right now. I don't know in the next 10 years whether we'll see really swift adoption of that or not, but it would be nice if there was. So
thank you, Bryan. Exciting times indeed.
Yes.
We only have a couple of minutes left, so I'm gonna ask this question of all of you, but I request brief answers here. So as a nation, we've targeted 2030 as the year to cut carbon emissions by half, with the goal of reaching net zero carbon emissions by 2050, and that is achieving a balance between the carbon that's emitted into the atmosphere and the carbon that's removed from it. So, looking through your lenses, what does 2050 look like for the laboratory, for electrified transportation, and for environmentally friendly solar farms. Catherine, please, maybe we could begin with you.
Yes, Suresh. So we actually put together a master plan for solar energy on site, and we have 7 large facility sites that are available that we're reserving for large scale solar energy installation. And so definitely by 2050, all 7 of these should be installed, working great, generating lots of on-site energy, hopefully coupled with batteries, maybe able to help offset, that high peak from electric charging and really helping us to have more on-site renewable energy. That'd be my outlook.
Wonderful. Thank you, Catherine. Brian?
I think by 2050, I think we'll see stuff like EV charging stations and solar generation and battery energy storage systems being as typical as today's water and sewer and lighting and HVAC systems that we have today. They'll just be commonplace, and that's hopefully where we'll be by that time.
Fantastic. And Yuki, the last word.
Yeah, Catherine, we have to expand our study to those other solar facilities in the future. And also that to the 2050, the Argonne will advance the science, not only just the bird, it's like other wildlife and also ecosystem, soil, water, how we could be friendly to environment as an ecosystem. The solar, how can the solar can provide the benefit to the ecosystem service benefit. So that we are kind of moving toward that kind of the more comprehensive co-benefit of the clean energy and ecosystems.
Thank you, Yuki. Our time has run out, unfortunately, but I really want to thank all of you, for taking the time to present and for the informative and engaging conversation. I also want to thank the audience for the thought-provoking questions. I hope you've enjoyed the conversation as well. At this point, let me turn it back to Robin.
Thank you all so much. Suresh, thank you so much for being the consummate moderator. And to our panelists and our audience, thank you so much for your collective contributions to this really, really important conversation. This event has been recorded. And as I mentioned earlier, we're going to email you this recording for your listening pleasure and to also share with your family, friends, and colleagues. Our next Out Loud is going to be June 21st, the first day of summer. So keep an eye out in the upcoming weeks for an email invitation with some additional details. We hope you've enjoyed your virtual visit with Argonne this evening. Stay safe and have a good night.